Hey guys, in the previous video we have already seen what is image augmentation, need for image augmentation, operations in data augmentation. And once having this idea, we have went through Image.io library and have used different functions available in that particular library and ImageAug and all the functions in the library. And having this basic idea and operations on images for augmentation, we have now moved to okay, how do we draw bounding boxes at the initial stage? And then after data augmentation, how can we draw proper bounding boxes? This is our topic to discuss for today. So for doing that, from imageaug.augmentables.pbs, we are importing bounding box and bounding boxes on image. Bounding box on image is a function which takes the argument as bounding box and the shape. Bounding box is just from where to where is actually the box that we want to draw. So from the image, it's clear that the car is actually starting somewhere at 90 and ending somewhere at 380, and Y it's starting somewhere at 30 and it's ending somewhere at 235. So very important thing than normal Cartesian, it's in normal Cartesian, we think this as starting of the Y and this is ending of the Y. But when coming over here, it's the top corner is starting of the y-axis. Okay, this is what are the parameters for bounding box. And along with this parameter, it takes the shape of the image. Image.shape would just return row, column, and number of channels. So this is about drawing bounding box and image. Now let's view it. It just takes this bounding box and we want to draw it on the image. So draw underscore on underscore image would take argument as on the image on which we need to draw this bounding box, and size equals to 2 is just to say the thickness of the border here. If you just make size equals to 1, the thickness of the border would be little less. That's it about the size argument over there. So now you can view how can we draw bounding box on the image. This is just a normal image. Now what if we translate our image? Let's suppose we are translating the image using IIA.affine. IIA was just, we imported image.augmenters as IIA. So now we are just using that image.augmenters. And we are using translate underscore percent just to say translate x-axis by percentage of 0.1, and it takes an argument of scale. For now, we are scaling it for 0.8. So now how do we draw bounding boxes? So you can just say move of image and bounding box equals BBS. So this move takes the argument as the image and the bounding box, and it returns the image underscore aug and bounding box underscore aug, BBS underscore aug. So now how do we view? So it's just I am show the bounding box which it returned BBS underscore aug dot draw an image. On which image we need to draw? We need to draw it on image underscore aug. So it takes the argument as image underscore aug, and again size equal to 2 is just for having the thickness of the box which we are going to draw. This is how you can see even after translating the image or moving the image, the bounding box is still as perfect as the previous condition. Okay, now what's the good situation when we rotate it? Okay, as usual, we are using IA.affine to rotate from -50 to 30 degrees. And then we drew the bounding box in this on this image. So just rotate underscore BB, the image in the bounding box. This was the original bounding box. So now when you view this image using BBS underscore aug dot draw an image, the image aug and size equals to 2, you can see that the bounding box is actually out of visible now. Like it's out of frame. The bottom line is not visible now. So how do we get into a proper fit? To do that, there's a little procedure to follow when bounding box goes out of frame. The procedure starts this way. First, we would be padding the image. So we would be padding the image first one border with a color C val as 255 is just to say to draw a white colored border, and using that border, on top of that border we would be drawing a border of CVAL equals to 0, which indicates draw a black border around the white border. So we can do that by just using ia.pad, which takes image and top, right, bottom, left as the arguments, and mode is just a constant mode. So this is how we can draw borders around the image. And then we are returning the image underscore border too. This will have both the white one and black one on it. Once having this, now let's define our draw underscore BBS function. So it takes image, the BBS, and the border. We are just defining 3 different colors to see whether is fully the bounding box is full, the image is fully within the bounding box, or it's partially within the bounding box, or it's not. So we have just run through BB and BBS.bounding underscore boxes, and we have seen, first we have called the pad function. After padding, then we have called, we are checking bb.bounding boxes. If it's fully within image, we are drawing green. If it's partial, we are drawing orange. If it's not, red. You can know the RGB compositions for particular color just by viewing it anywhere online, or it's just RGB. So for red, it would just be R to be 255 and remaining to be 0. For green, it's just G to be 255, and orange mixture of R and G with this proportion gives you orange color. So that's how you define your green, orange, and red colors. Once having that, now we would be seeing how do we shift. So image underscore border would be bb.shift, left equals to border, top equal to border, because in the image, the problem is not with the left and the top. So now we are just, after shifting, we are drawing on image with image border size to and color is whatever the color we get it from here. So now it would return image underscore border. Having this as our function, now let's apply this bounding box to our rotated image. So again, we are just doing rotate equals ia.affine of rotate, which takes arguments of the angle which we rotated. After that, we are drawing the bounding box by using this rotate. It gives image underscore org and bbs underscore org. Now we are calling draw underscore bbs function with this particular image, with this particular bbs underscore org, which will be removing which are out of images, and the border would be 100. So having this as the arguments for image underscore after, I repeat, it would take image, it would take the bbs underscore org which we got from here, remove which are out of image and which clip out of image, and remaining would go for this function, and then we would get the border. It's stored in the variable image underscore after. Now we are going to view that using im show of image underscore after. So now when you see that, you can see here the bounding box which was out of bound before now is into the screen. So now the bounding box is clearly around the car. This is how we can use bounding box functions when we rotate image or when bounding box goes out of the frame. Okay, so let's have a quick review from the start. First is what's image augmentation, and next is need for augmentation. Next is operations in data augmentation. We have imported all the libraries and we are using ImageAug library. We read the image. After reading the image, we applied a rotate, additive Gaussian noise, adding blurring to the image, and then we cropped the image, shear, which changes the orientation, and then flipping, and then gamma contrast in the image, and then scaling the image. And then we went through bounding boxes. First is drawing normal bounding box, and then how to draw a bounding box when it's translated, and how to draw a bounding box when it's rotated. When it's rotated or when other operations are performed, original bounding box might go out of the frame. To get it into the frame, we would be padding the image first, and then we would be drawing the bounding boxes using this particular thing. So now after rotating, whatever the arguments we get, we are going to pass it to draw underscore BBS function, with image, and VBS underscore org dot remove out of image dot clip out of image as the argument and the border to be 100. And now when we view this image, the bounding box is clearly into the frame and exactly around the car. This is what we wanted to learn by using bounding box on images. Thank you guys.